Right, so we have another question on the normal distribution. This time we have the weights of a group of children that they are normally distributed with the mean of 22.5, so that's the mean, and the standard deviation, which is 2.2 kilograms, so that's the standard deviation. Part A, write down the probability that a child selected at random has a weight more than 25.8 kilogram. So let's just go down here to put the basic elements on the normal distribution. So the mean we said is going to be 22.5 kilograms, and the standard deviation is going to be 2.2. I don't need that at the moment. All I need is to be able to identify that the 24.8 kilogram, it's going to be on the right hand side of the mean. So let's put the 25.8 somewhere here. It doesn't have to be super accurate as long as you are having a good understanding about the area that's going to be shaded under the curve. So we want to calculate the probability. Let's just assume that W is the continuous random variable that corresponds to the weight of the children. So write down the probability that the child selected at random weighs more than 25.8. We want essentially to calculate for part A the probability that W is bigger than 25.8. And if I was about to shade that area to see the corresponding image, that would be what you can see now on your screen. So how do we calculate that? I'm going to need the use of my calculator with the menu, and then I need to add a calculator, of course, otherwise I won't be able to calculate. And then back into menu, probability and statistics, and then distributions, and then I want the normal CDF, which is the cumulative density function for the normal distribution. The lower boundary is what I see here because I want it to be more, the 25.8, so 25.8. And then the upper boundary can be any large number that's already large enough. We cannot, we could have used infinity, but we cannot write infinity in the program, so we better use just a little large number. The mean is going to be 22.5, and then the standard deviation is 2.2. And then once I press tab, I should get the answer, which is the 0.066807. What is a good practice is to first to write down what you typed on the calculator, or even better, if you write the command term that you can see on your screen, CDF, and that would be 25.8, comma, then the upper boundary, use infinity, then 22.5, and then excuse me, I forgot something. I forgot the standard deviation, which is 2.2. Then a good idea would have been to write down the complete answer that you have on your calculator. So the 0.066807, and then the approximation to two significant figures. Remember, zeros at the front do not count as significant figures, so 668 should be the correct answer, rounded to three significant figures. I don't need that bracket. Let's just correct that part. Let's correct the 8 too, and then three significant figures in a bracket to provide a little bit of information about the level of rounding. Part B, let's clear that up, and I mean the normal distribution, so we can use it again for the part B. The part B, let's make the part B with green. It says, of the group 95% weigh less than k kilograms, find the value of k. Now we know that that area that I'm sending now is 50%, So to go all the way up to 95%, I would essentially should reach more or less that point here, and that would be the value of k. 95% means that the area under the curve is 0.95. And to calculate that part B, I should use the inverse normal distribution because I have the probability, and I need to find the value of k. So I'm working backwards. So that would be now probability distributions and then inverse normal distribution. And now the area under the curve would correspond to 0.95. The mean is 22.5. The standard deviation is 2.2. And then once you press OK, you should get the correct answer, which is the 26.1187. So let's write down the inverse normal of 0.95, 22.5, 2.2. Let's put the full answer that we have there, 26.1187, and then the rounded answer to 3 significant figures. Maybe I can fit it on the left now. That's okay. I can put it here, 26.1, and that would correspond to 26.1 kilograms. So just to make some sense of what we actually calculated, that says that 95% of the children weigh less than 26.1 kilograms, which kind of makes sense if you think about it. And then for the part 3, we have the diagram, and then we have to work with the diagram again. So let's just do that. Let's just clear that information which was there for the part B. And says on the diagram below, shade the region that represent the following information. 87% of children weigh less than 25 kilograms. Well, we already know what is the mean, which is 22.5. So the 25 would be on the right. So let's just put 25 somewhere here. You could use the standard deviation, which we know is plus 2.2, right? And then another plus 2.2 and so on. So that should be the region that goes all the way up 25 kilograms. And then it says 85% of the children, 0.8087 would be the area under the normal curve. That should be enough to represent that information.